All right, good. So people joining the live stream, we are talking about RDF and SPARQL capabilities in the upcoming version of Wolfram Language. So let's just get a sense of what we're going to cover here. Tony.
So the idea is that this time we could look at the query language itself and the design that we have done for it. But to remind ourselves, I prepared a small overview of all the capabilities, and then in the second section we can look at the query language in detail.
Okay. Great. Okay, so these are, I don't think I've seen these guide pages. These are your guide pages, yes?
Yeah. So from these 3 guide pages, you can reach all symbol and format ref pages that are new.
Okay. Why isn't that a capitalized C? Has this gone through DQA?
They are looking into it.
Okay, all right, fine. Okay. Boy, okay, all kinds of stuff here. All right. What is the analog of SPARQL select in the SQL world? I know that it's select in SQL, but what is it in our SQL, in our database integration system?
I mean, the equivalent of this layer, we are not documented at this not now, but
okay, fair enough.
Yeah, there's a thing called database select field we use internally. It's really just for us right now a common target for compilation of the entity queries.
Okay. All right, fine. Okay.
And when dataset comes, also dataset will compile to that.
Okay. All right. So now, first question is sort of the big picture. What are people going to be able to do with this? What's the pitch for this? Why do we care?
So in the overview, I explained 4 different scenarios in which you can use SPARQL. One are in-memory RDF data that you can query. The second one is you have a SPARQL endpoint, either remote or local on your machine. The third one would be querying entities, and the fourth one, querying relational databases using SPARQL. But the last 2 points are future. Yeah.
Okay. So wait a minute. So how does this relate to what we're doing with the database integration project?
So this project is based partially on the new database integration project, at least on the intermediate layer.
Okay, but why do we care about this? This is to use the query language of SPARQL on a relational database? Is that the idea?
Yes. Yes. And it will become apparent why that might be useful if once we review the whole query language, because it's in some sense simple, and the mental model in which you think about these queries is different. So it might be easier for people to write a SPARQL query than a SQL query.
But wouldn't it make more sense if we did that at the entity layer level? So you invent some kind of...
That is also a possibility. But in this particular case, I'm using R2RML, which is a standard. Yeah. But I don't...
What I was saying is just that if we invent entity level primitives that correspond then to a SPARQL primitive, and then the SPARQL primitive correspond to an SQL primitive, then we just go and translate through these steps.
Okay.
So we keep this piece of R2ML.
Well, let's come to that in a minute. Okay. So here's a trivial question. Why isn't there a mouse over of this entity?
I don't know. I can look into it.
Okay, but there should be, right?
Yes, the input form should be there.
Okay, all right, okay. So what is this? This is a SPARQL query against the entities system.
Yes.
How does that work?
So the idea is that entity data can be viewed as a triple graph, in the sense that you have an entity and a property thereof and the associated values. So these are naturally some triples. And then effectively, you're creating that graph and applying that query to the graph. But internally, it's going more efficient in some cases.
Okay,
But
right, okay.
when you write entity isotope, are you really intending entity class isotope also?
No, it's about the type which has more information than the class itself, because it has type information.
But that's not a single entity in any sense.
No, it's not a single entity, correct.
Okay, so let's take it from the top then. Okay, so in-memory RDF, so what is this thing? This is a particular database of what?
It's just some data found on the internet. Library of Congress published some classification systems, and one of them is about genres. Yeah.
Okay.
If you want to evaluate these things, maybe you could evaluate the things in common namespaces. Yeah. So these are.
Okay, so let me explain that. Explain this. So these are things out there on the web that happen to have IRIs.
Yes. So each resource and each property is identified by an IRI. And to not write them out all the time, I included some short forms.
Okay.
So.
Okay, what are these prefixes?
They are used later. You could evaluate them too. Yeah.
Okay.
But we'll get to that.
All right. Okay. So now let me try to understand what on earth this is. So for example, let's say I take this RDF graph. Okay. So what would happen if I, for example, wanted to visualize this graph?
That's in general tricky. I have started
Hypergraph or what?
I started implementing something, but it's not ready.
Okay. So what if I want to just get the entities in here somehow?
So you would write a SPARQL query.
Okay. How do I get the triples, for example? There are only 4,000 triples. So how would I just show all of them?
You could apply edge list to that RDF graph.
Okay. So, well, if I say vertex list of the genre graph here, so this thing is a graph. It's a bona fide graph. Is that correct?
It's an RDF graph, and I'm not sure if we should be reusing the graph functionality in that way, like you just did. So
remember, Stephen, that's not technically a graph, but a hypergraph.
It is a hypergraph, right? I understand.
So the correct way.
So, for example, if I say find, what is the thing for finding connected components? Graph
that won't work.
Okay. Okay. All right. So this particular IRI, what is RDF lang string?
It's a language tagged string.
What does that mean?
So that means the first argument is a string and the second argument is a language tag, like English or German.
But why is that a funny name that isn't one of our types of names?
So it's one name I proposed, and we can use a different one.
It's not going to make it. It's not going to make it. A thing with a lang in it is not going to make it.
So it's as close to the standard as possible, but yeah, we can choose a different one.
Well, if we're going to call it a language, why don't we just call it an RDF string? And then this language thing, why don't we say language arrow English if we're going to canonicalize that way? And what is this RDF blank node? What are all these things? So if I say, let me just do oops, that's really weird. Oh, whoops, that's not the right thing, is it? Okay, so all right, so we've got a few rogue creatures here.
Yes. So these blank nodes. So first of all, each of these IRIs, they are nodes in the graph. But sometimes you might want to introduce a node that is needed to connect certain pieces, but that you don't want to identify. That's what you use these RDF blank nodes for. So they just have identifiers that are just meaningful inside that graph, but not outside.
Okay, well, so I mean that's a weird name. Okay.
Also, again, a standard name.
Yeah, but I understand, but we're not doing that. I mean, we're trying to map these things into our own structure, right?
But we probably want to build our very own one in the future. This is kind of more a SPARQL representation in our language.
Yeah, I know, but we need to spell out the words and things. And I don't know what a blank node is, since we have a thing called blank in our language, right? So if you describe a little bit more what it is, then we can. I mean, I don't know what is B4. Is that that's its name somehow?
Yes, that's an internal identifier. That's just scoped to that graph. And blank refers to the fact that it doesn't have a global identifier.
So why isn't it some kind of local? I don't know what that should be, but that's clearly not the right name. Okay, so let's keep going here. I mean, show me something where it's really like a wow, this is useful type thing, rather than toy examples. Is there some case where we can see something on the web where we can say, wow, we can really use this?
I can think of cases where we are using it internally where it's extremely useful, but I can't really sling out examples right this moment. But we're using this we have a local Wikidata mirror that is constantly updating. And so we're using SPARQL queries to determine people who have died in the past week. Okay. Or who have had death dates updated in the past week or past month, as well as other properties have been updated for them. Lucas Bantner is in the process of making the people data scraper that runs regularly use this SPARQL entities, this Wikidata entity store that I've set up.
Okay, so other than Wikidata, what other useful SPARQL things are there out there?
DBpedia has
that's another Wikipedia.
That's another Wikipedia thing.
Anything
there are many other. Tony is the name LIGO. Is that what I'm thinking of? Where it's kind of a federation of ontologies that includes DBpedia and Wikipedia and several linguistics-based ontologies, connecting word meanings and such in different languages through an RDF triple store and making it all SPARQL queryable.
So what? I mean, we've already got a bunch of that capability. I don't know what we've got. Our dictionaries are becoming hopefully better than any other dictionaries that are out there. Yeah. Okay. All right. Fine. All right. So this is the continuing concern with this stuff. I mean, hopefully there are some actual, commercial customers out there who have this stuff and care about it, and hopefully we will be able to use this technology internally for some purposes.
We are definitely using it internally for purposes, and it has streamlined a lot of workflows.
Okay, that's good. All right.
It has really worked well for us.
Okay. So SPARQL property path. So this is.
Yeah. So the point is the SPARQL select takes as a first argument a graph pattern. And graph patterns are defined recursively. And one of the possible elements of a graph pattern is a property path that has a start and an end and a list or a pattern of visited properties.
Yes. Okay, so for goodness sake, let's just call this RDF string if we want to do that. Make sense? And this quotes EN, we can support that, but I think we should also support language arrow entity English. Does that make sense?
Yes.
Okay. I'm not even going to guess what a SPARQL inverse property is. And this thing here was one of those things that was a specific, was that an IRI or was that?
Yes, this is one of the commonly used prefixes, or at least in that particular ontology. Yeah. So maths of a string gives the namespace II together with that local name.
Okay. Okay. SPARQL variable. Why do I need that SPARQL variable for the SPARQL select? How is the first argument? I'm totally confused here.
So the first argument has a number of in-scope variables, and the solutions are basically ways in which this variable can be replaced such that the pattern is a subgraph of the whole graph.
Okay. All right, so let's understand what this would normally be. This would be some kind of graph. if we had a graph pattern, that would be, that variable thing would be something where there's a subgraph and it's named X, and we're getting that X out. Is that correct?
Yes.
Okay.
And probably
but this is a very different pattern structure than we would normally have. I mean, this is the equivalent of parent colon, you know, blank, SPARQL blank, so to speak.
Yeah, it would be parent underscore.
But it's not too dissimilar to solve, in a sense.
Solve, you said.
Yeah.
Yeah, okay. Where we're trying to, right, but the way this is working, this is a property path here, and that simply contains the variable, and it's asking us to basically, I mean, this might better be named something like, I mean, this is implicitly finding those things which are variables in this path. So it's finding all paths with respect to, and it doesn't have to say with respect to some, where is it describing the graph? So it's saying the graph is part of this sequence here.
Yeah, so maybe it's clearer once we review the syntax later, but
okay.
To start, we are starting at the label Tango Music, then we are going backwards the label relation to get to the node of that Tango Music thing, and from that we go to the broader concepts, and once we reach a broader concept, we take that label again. So that's
okay, so this is doing as many broadenings as necessary.
Yes.
So why are the three arguments SQL SPARQL property path has, why is this in a list and the other arguments not in a list?
Because the first argument is something that's appearing in the subject position. The last argument appears in the object position. That means the first and the third argument of a triple, while the inner things.
I see. It can go and go as many links as it wants.
Yes.
But in that sense, it would be quite different from entity property path.
Yeah, I mean, so this is this is an arbitrary triple, which is being called a property path here. And you're essentially saying you're putting this variable in here. I could put a variable in anywhere here. Is that correct?
Yes, in our implementation, we can have a variable anywhere. In SPARQL, you can have variable in the first and the last argument, but not in the property position.
Okay. All right. But anyway, so you're able to solve for that variable, basically.
Yeah.
Okay. Okay, so this is raw SPARQL.
Yes. So the point is that you can use either the symbolic or the string version of the queries interchangeably.
This is presumably rather trivial to implement, yes, the SPARQL query thing. SPARQL execute.
That one, yes.
Right. So, okay.
I have a question about this query. Those seem to be both pictures of Mont Blanc. Is there a way to say that you only want one picture per mountain?
Yes, but that would make the query much more complicated and distract from.
Okay, so where is this question mark image thing? What is that? I understand why this thing decided the SPARQL variable was called image. Is it this one here?
No, every question mark text is a variable in SPARQL, and we translate it to SPARQL variable of that text.
Okay, but so why isn't it solving for the other variables here, like the names of the mountains?
Select and then a sequence of variables projects to these variables. That means the others are not readable.
So it's this variable that's being solved for.
You can also put a star there, and then you get all.
Here, so do I have a question mark star or just star?
No, just a star.
What am I getting here? That's amazing. Why is that number of so high precision?
It's still to be fixed.
Okay.
There's currently, there's a not so easy to represent all of the data types of RDF in the Wolfram language.
Okay. Why was this so slow?
It's taking Wikidata about 3.5 seconds, at least the last time I tried. It's not on our side. But,
okay. But we have a mirror of Wikidata, yes?
Yes, we do. We have two, in fact. One which updates pretty instantaneously. The other one updates very slowly. It's on common.
Right, but so these queries we could in principle do against our own mirrors, yes?
Yes.
yeah. So in principle, just the URL has to be replaced.
Okay, okay. All right, okay.
So in the second example just shows, in place of a string, you can use a symbolic query, but it's not an interesting query, just to show. Yeah.
Okay, but so if I said in here, if I want to say, I don't know what these triples actually are doing, but give me a case where, so that was limit 2, and I don't understand this limit. Why isn't it called max items? Which is what we would normally call
the standard. There is limit and offset. There's limit and offset following the standard.
Okay, but what are we doing here? I mean, I don't understand why we're even bothering. We could just use this syntax if we're just going to, map everything into. Why are we bothering? I mean, I thought we were trying to make this so that it was actually, something, it's friendly to our language. In which case, this would be max items, and we don't have an offset concept, but we could certainly, I think that might be a useful general concept, right?
It's related to take, where you have
of course
list, comma, nm, and take.
I'm well aware.
Yeah.
Right. So I mean, we could do that as part of max items. Actually, we could have max items start. It would be an interesting idea for in general to have that be a list with an offset. But in any case, I mean, okay, so what's an example here of where I can do something interesting? What can I put into this property element here to, like, I don't know, what do I put in here to get this to do something interesting?
Well, at Wikidata, you could look up what are their properties and then find some interesting.
Okay, so, well, actually, this is in SPARQL execute. So how would I look up their properties? Not using SPARQL execute.
Yes, you would have to go to the documentation.
Whose documentation?
Wikidata documentation.
Why doesn't it have a discovery interface? I thought that was the whole point of this kind of thing. Why can't I just look up its properties, but just by going into the RDF structure?
You can also write a query that gives you the properties that it has.
Okay, but I mean, can I write a symbolic query easily?
Yes. Yes. You can modify that query, add another option, distinct goes to true, and project to the variable y.
By the way, on our live stream, somebody is asking, why not just add hypergraph and graph query backed by Titan or some hypergraph database? Because if we add hypergraph, we'd love to add hypergraph one day, but there will be a boatload of things that we have to do to support hypergraphs in a serious way. I mean, I don't know. I mean, have we even thought about, Michael, can you comment on that? Have we even thought about what it would take to support hypergraphs in a useful, broad way?
I think Roger and Charles, we had some discussion, but not in any comprehensive way.
Okay. I mean, it's also not clear. I don't know how canonical kind of the things one does with hypergraphs are relative to graphs. Okay. In any case, let's keep going here. I want to get into the syntax and so on. I'm giving you a little bit of a hard time here for the same reason I have in the past, which is that I've just, it's wonderful to have all this capability. I just, I hope that there are real users for it.
And that's a quick preview on how you would query entities, both alpha and.
Okay, so this one, so how did we manage to do this? I mean, in other words, is this a SPARQL enabled version of our entity store, or is this simply you operating this stuff with respect to an existing, mapping this stuff into our existing entity store capabilities?
So implementation-wise, Alpha didn't get any new capabilities, so it's being evaluated on the client side. But it's trying to minimize the data it has to download to correctly match that graph pattern. But this is not done yet. It's not fast enough. So that's why it's for the future.
Also, it's probably, I mean, to my eyes, it looks weird that you're mixing, let's say, 2 layers of abstraction.
I think once you define how an entity domain should look as an RDF graph, then you're fine, I guess. Now, here's a query.
What are the 2 layers?
Well, one is the entity layer and one is the SPARQL layer. I mean, at least from the point of view of SQL, we kind of have similar constructs that are much closer to SQL than to entities, but you strictly cannot operate on entities. So all the entity queries compile to this layer, but the layer doesn't know or care about entities.
Okay, let me ask another question here. Okay, what is the impressive thing that one can do for, as a result of the symbolic mapping of SPARQL that one couldn't just do by writing SPARQL queries?
So the point is that you can write programs that look still elegant. And the whole thing started when I tried to back some entity store by a SPARQL endpoint, and I had to do a lot of string joins, which was ugly. And even to get the simplest thing, I had to write a page of code. And with that, you can have a nice, clean thing separated into small functions. Yeah. And I've written already 2 such programs.
So you've written a few, or you said 2?
2 slightly bigger ones, but yeah.
For what?
One is for visualization of RDF graphs, which is not ready yet. And the other one is an importer of an RDF-based format. That means the whole information of this format is encoded as an RDF graph, and then you use SPARQL to extract it. And these SPARQL queries are monsters, but because of the symbolic representation, the code is still nice and readable.
Okay. All right. Okay.
And these 2 queries here that you see using alpha and the entity store, they're both constructed so that you can see those are things that are not easily doable with our current entity capabilities. Unless
I can see that. But I mean, but what we've hoped for, okay, so let's look at this. So I don't know if I can really run this in a reasonable way. Okay, so this is saying there is a sequence. Oh, wow. Okay, so this is downloading every isotope.
Not every, it's a little bit optimized, but I'm still working on making it better.
And why doesn't that engage with Nick's caching framework?
Other technical reasons that I am planning to look into.
Okay. All right, but so let's take a look at what this is doing. This is essentially a thinking, it's essentially a graph pattern that says you start from Mercury 204, you end up, you can do as many daughter nuclides as you want. And then I don't quite understand what this is doing. This is just saying at the end, so this is saying the decay chain of Mercury 204. Well, let me try something a little bit more interesting. Let's try the decay chain of uranium 235. Okay. I wonder if I type U235, is it going to work, or is it going to think it's a submarine? Okay. So that is a long decay chain. Okay. That's pretty nice. So I see. So this is, so let me understand this, what this did here. So what this is doing is it's saying, consider the entity property thing as a link in a graph. And now, I mean, but if we were going to do this in our own syntax, I would have expected something slightly different. I mean, I would have expected, this is a pattern, what's happening here is that, essentially f of x of x of x of x, this is the case of, this is the case we don't have, which is the nested function application, right? I mean, so in other words, if we had a list, we would be able to say x dot dot, and that would match any, x, 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 x type thing, right?
Yeah.
But this, which is essentially what's happening here, we don't have, and we've talked about that. What did we think of calling that, Michael? Do you remember?
I was not in such a meeting.
Okay, but were we to have such a thing, then what this would be, in effect, is, because this thing is, if I take U235, clearly what I'm doing here in the entity property land is to say this thing of wherever it is. How do I pick that creature up? What is going on here?
Maybe triple click.
I'm trying all sorts of clickery. There we go. Okay, so this would then give that. Interesting that this didn't get hung up on the missing. What did that mean? Oh, variable. I see. It's a variable. Okay, that's because U235 undergoes spontaneous fission. I mean, sorry for the physics moment, but I assume that's the reason. Does Michael have a comment on that?
I do not know offhand why.
I think it does spontaneous fission and ends up with different output. But so that missing didn't tangle up the SPARQL query for some reason.
Yes. The reason is, well, we could talk about that design, but that's why it's still in the future, considered as a future feature. So the thing is that this property, .plates, returns a list of things. And in RDF, you would usually represent it as a list of triples. So you would have 3 times uranium, various times in the subject position, this uranium 2, 3, 5. In the predicate position, this property, and then one of these values. And I'm not keeping the missings, but it might be possible to keep them.
By the way, this is it's interesting that this problem has these two problems have two corresponding problems in plain SQL, which is one, the way that missings are propagated is slightly different from in the Wolfram language, and two, that there is a normal form and that's different from the one of the entities.
Okay.
That we also have this thing, like we cannot represent lists of things.
Yes, right. I mean, but that's a SQL weirdness.
Yeah, but it's similar here as well. You never have a list valued property. Right. You have several properties. You can repeat properties.
Yeah.
Right. Okay. All right. Fine. I think I'm beginning to understand that. All right. So let's go down here. All right. Now you're going to talk about the query language. Boy, oh boy, oh boy. This looks really horrifyingly complicated.
This is a quick overview of all SPARQL features, and it contrasts both the query string versus the symbolic representation.
Okay.
So to see which feature maps into which.
Okay, so this is the raw SPARQL query, and this is saying SPARQL select of an RDF triple of what is EX? That's some IRI. Is that correct?
Example.
But the IRI is that EX thing is just an IRI subscripted with has father. Is that correct?
Yeah, it's basically that IRI that you see there. I'm using this example.
Oh, it's got a string concatenation in the IRI.
Yes.
Why is it that you don't have a subscript, that you don't have a subvalue for the IRI which does the string concatenation? In fact, that will be an interesting idea for URLs potentially as well.
What's the
So my idea would be, if that's what you always end up wanting to do, is that string concatenation, why not simply make it that this IRI with a string here concatenates that string into the into the form of the effectively URL. Is that an obviously stupid idea for URL, by the way?
I don't know about for our URL, but just maybe I'm missing the point, but it's just way quicker to type EX as father.
No, you're missing the point.
I'm missing the point, okay.
Like, there is one thing I'm not convinced. I mean, when you compare the SPARQL query with the SPARQL select, in the SPARQL query, you have a way to define prefixes at the beginning. And I would say, I mean, and then you give them a short name. So why don't you have a 2-argument version of IRI and in the select some kind of header that defines what the first argument is?
That's exactly what I had before, but I removed that design because it led to the possibility that people use 2 different ways of shortcutting things. And it turned out that what you just proposed actually cluttered the code more than using these short prefixes. So I actually removed this non-feature or unfeature.
Okay, so listen, one thing I want to talk about, maybe we can get this into an LCC or an ILD meeting is this idea just had of having this kind of sub-value mechanism for all of these things, including things like file, that would allow you to basically just go and, it's just a way of adding a piece to the path. Am I making sense?
Well, for files, it might make sense because they are paths. URLs are not paths, and sometimes you don't want to, like, you want to add something.
I understand.
Like,
do we have a project manager in this meeting?
No, we don't. I can.
Okay. Could you make sure that gets forwarded to those guys?
Yeah, I can.
Okay.
So my claim is that the useful thing for URLs would be just string join, because sometimes you would just want to.
Okay, let's not do that in this discussion. It's just an idea that we could put on the shelf for later. Okay, so I want to try to understand. Okay, so there's a filter here. So that's the. Okay. I don't understand. Okay, so that's part of. That's part of the pattern that is in the SPARQL select.
You can also put the condition directly next to the triple with the year in it, so both is fine.
We took a slightly different path here. We have a different head that does the where.
Which is?
Database where, but it's internal. But like, we don't overload an existing the existing condition thing for this.
So I tried to reuse Wolfram Language features whenever they were basically a correct match for that feature, like in the case of alternatives, which stands for union, or except, which stands
Why
for.
is this optional, not what?
Optional can wrap any other pattern, in this case, just a triple pattern.
Why isn't it just the Wolfram Language optional pattern construct?
Because optional behaves a little bit unexpected when just used purely for pattern matching. I had discussed it in a bug report. You need to have a function and define a default and things like that. So optional is not the right match.
That's probably wrong. We probably should support it directly in pure pattern matching.
I had filed a bug some years ago where we discussed it.
I mean, I learned very early on to use repeated 0-1 instead of optional.
Yeah, exactly.
Which is horrible.
Can we discuss that in LCC meeting, please? Could you bring that up again? Thanks. Okay. SPARQL select, okay.
Yeah, you match a pattern only if the other pattern doesn't exist, and so on. Here, these property paths, there are various constructs and they can be nested.
Okay, look, this stuff is really complicated. I mean, what do we think is going to be the flow here? Do we think there are things where we can translate natural language into this stuff and get something useful for Wolfram Alpha type queries, or what?
There are some projects out there that do natural language.
Yeah. I'm not interested in the toys. Is there something we actually think we can do that, that we can't do right now that this will allow us to do?
Using grammar?
I think definitely. The question is only that this complicated query that can be expressed in the language are not so common queries. So it's not obvious if the effort is justified to do it.
Right. Well, right. And that's the question, is that's what I'm still pushing on, is I'm just trying to understand, okay, so, this doesn't look so hard to read, this SPARQL query. So what, again, what's the example? So you're saying if you want to construct this programmatically, it's obviously much easier to use a symbolic structure than it is to use, just a string. I get that.
And I found various blog posts on the internet where people are exploring ways to construct SPARQL strings. And I think this is the solution, because you can convert from and to SPARQL strings.
Okay, how do you convert from this SPARQL string to this symbolic representation?
Import string of that thing, SPARQL query.
Okay, so can I run that?
Including the prefixes.
Okay.
Because otherwise the prefixes are not defined.
Okay. All right. So if I take this and I say, okay, so let me get that there. Chomp. Okay. And now I say import string of that thing, comma, SPARQL query. Is that right?
Yes.
Interesting. Okay. What does SPARQL construct? Oh, that's the same thing you had there. Well, that's cool.
And
Yeah,
that'll round trip.
That is very cool.
Yes, they do round trip from after a few things, after a few rounds, they stabilize.
Okay.
Yeah. Now it looks a little bit longer because you didn't specify the prefixes, but you can have an option there prefixes goes to, and then you have the short form again. But it's a detail that's documented.
That's interesting. I mean, this is interesting. Okay. So again, in terms of constructing the SPARQL query, I mean, what do we think that the source for constructing a SPARQL query will typically be, other than people writing, their own code to do it?
Well, in my case, it was always me coming up with it because it might be really tricky to come up with the right queries. So I build it piece by piece.
I'm not sure kind of what you mean by source of the query. Isn't the query not always something that's very subjective and...
Yes, I understand. But the point is people understanding, because there is a dearth of actual SPARQL sources out there. I'm trying to understand. I mean, does NIH, some of these government entities, seems like they were at least talking years ago about having, everything's going to be an RDF something or other. Did that happen? I mean, people, particularly with enthusiasm in the government sector for, triple stores and things. I mean, that's what
the mesh. The NIH has done a bunch of SPARQL stuff, as has the Library of Congress and other similar agencies. Agencies that handle similar data in the government have indeed gone and made SPARQL endpoints for their assorted vocabularies and.
So I think
PubChem has.
Yes, I think you are right.
I think Crystal was playing with some kind of Library of Congress SPARQL endpoint, and it was quite brain dead. I mean, that is it. It was heavily throttled, and it wasn't clear what the point was.
Yeah, Library of Congress doesn't have one anymore. I have running on my Linux box at Rye 2 Library of Congress SPARQL endpoints right now.
That came from were what, earlier Library of Congress products?
No, from downloading the triples from them, that download site that you looked at way at the beginning of the meeting, and then loading them into a triple store engine, and then just pointing Mathematica's SPARQL select to that endpoint.
So we are not planning to have our own triple store engine. Is that true or not true?
I would love it if it were true. I think that's more for Tony.
I'm not sure if I understand the question. We have an engine, we have a full implementation of SPARQL, but maybe you mean we won't have a SPARQL endpoint that people can...
I think Stephen means the fuel for the engine, not the engines itself.
No, actually, I was asking about the engine itself. Okay, so great. So because like in the case of SQL, we don't have a local SQL engine. We're using the external SQL engine.
Yes.
And so in this case, we have a local engine.
Yes. So these queries that you see there, either the symbolic or the query string, you can apply it directly to an RDF graph, like the example above, and it will work. So this is evaluating.
Okay. So wait a minute. So the RDF graph. So one of the things you've done is you've got import formats for the various things that are out there. So do you have all of the things that people like a .rdf file or something? Is that now importable? Yeah,
we have 6 importers. The most important ones like Turtle, RDF XML, JSON LD.
Cool. And that is importing into this framework, is that correct? Or like an RDF, what does it import into?
It is returning either an RDF graph or an RDF dataset. An RDF.
What is it? What is an RDF graph? Is that one of our ordinary graphs, or is that something different?
An RDF graph has had RDF graph, and it's basically a list of triples.
Which is, it's some kind of hypergraph, ultimately. Is that correct?
Yes, an ordered hypergraph or something like that.
Okay.
Or genetically can be. It doesn't have to be a hypergraph.
But given that object, it is then plausible to process it with standard Wolfram language functions and make a graph that you can visualize and all that kind of thing. Is that the idea?
So you can look at a RDF graph documentation, and there are two examples where I show a possible conversion to and from a graph.
You said RDF graph?
Yes. In the properties and relations. So this converts a graph. So yeah, this output is still wrong. It should be bigger. The out one.
Okay.
So this converts an RDF graph to a graph. And
what is that property thing?
It's the graph specific or.
Okay, all right, okay. So which is now going to be an annotation.
Yeah, if you can zoom that graph of the output bigger, then you see what's happening there.
Can you do normal?
Of what?
Of RDF graph to get a graph?
No, because there are different ways in which you might choose to represent it.
Okay, so what's the converter then? Sorry, what was the zoom here on this thing? No.
On the graph above there.
Oh. Okay. Okay. Okay.
So
okay.
it's tricky to encode the RDF information in a normal graph object.
Right. Okay. So again, just zooming out for a second. So, you know, the places where this is going to be valuable are people, customers, others who have large existing triple stores. Is that true?
Probably more people who use large existing stores.
Well, which ones? Tell me which ones there are. Because so far you're not convincing me on that.
The latter is more popular.
Which latter?
The latter thing Michael said there.
Okay, so what are the big triple stores that people are using?
There's the ones that we've covered so far.
Okay, so there's the Library of Congress, which closed it down.
Right.
There's, okay, so that's one strike down, okay? There's Wikidata, which is alive. Okay,
right.
What else is there?
I'm going to send you a link in Messenger of the thing.
Okay.
A bunch of stuff.
PubChem. What aspect of PubChem is interesting for our purposes there?
We haven't looked yet.
Okay. Okay. I mean, do we believe, I know in past years there have been customers who had large triple stores and were interested in doing things with them, but I frankly haven't heard about that for a while.
I spoke with Nate and he said he has a few.
Okay. All right. Okay, great. Have they been shown this?
I forwarded him email, I don't know.
Okay. Somebody is asking whether we have an analog of query service, query helper. What is this? This looks like a page of examples.
It's a user interface for constructing these queries.
Ah. And?
No. But I'm actually sometimes using that input to construct example queries.
Okay, that looks nice. Okay. But in principle, we could probably build that, although it's not clear, given the lack of
Yeah, I would prefer first finishing.
Yeah, I was just communicating with a chap who was responsible for this page, I believe.
Oh, really? Cool.
Yeah.
There's as Alan observed, pass this. So this is what I was trying to think of earlier on when I said LIGO. There's a lot of dead SPARQL endpoints in there, but plenty of places to download data, build your own SPARQL endpoint. A good thing, something Tony hasn't mentioned, is that you can do federated searches through SPARQL. So if you're searching for something on DBpedia and it has a Wikidata ID, you can go and pass that.
That's the point of an IRI.
Right, that's exactly the point. And so this website here that we're looking at is showing all the interlinking amongst all these different SPARQL endpoints. And
so presumably we could regenerate this picture.
Presumably, yes.
Okay. And what fraction of these do we believe are alive? So, I mean, this is a page.
That's a great question, and I'm really curious. I'm really curious. I can. How
do we get? Is there an easy way if I just took this SVG?
If you click on a blob, it'll take you to a page that gives you.
No, I understand, but I don't even know how many circles there are in that picture.
So I know it's a mess. Yeah.
I was hoping I could just.
1224.
How many?
1224.
How do you know that?
There's a web page.
Oh, okay.
Yeah.
Does that just work?
I'm really good at counting.
No,
there's also a JSON version of this that you can import.
Oh, I see. Okay. Okay. All right. So of those 1224, how many do we think are alive?
I poked at a random 10 a little earlier in this meeting, and more than half of the ones that claim to have open SPARQL links, those links were dead. And the ones that were live mostly seem to be from going through the same separate bioscience portal.
Okay, that's not very encouraging.
Not promising, yeah. That was just looking at the ones that had sort of live SPARQL endpoints. There were many of those did have live links.
You could have imported.
You could download the whole database. You could get a dump, get a full RDF dump of the thing.
You can import the JSON directly from the URL.
Yeah. Okay. Okay. So. Okay, but so it continues to be my question. You know, where is there this stuff in the wild?
I think it's something that really hasn't settled yet. It's the whole dream of the semantic web.
I'm well aware. Yeah, I've been hearing this for years.
Right, as have I. But it seems to be finally gaining traction.
Why is there evidence that it's gaining traction?
Just anecdotally, just from communicating with library friends and such, they're more interested in building data repositories that are linked to other data repositories and sharing their data in this way. And SPARQL is the way to query that linked data.
Great. Well, we're doing a service. Hopefully they appreciate it.
I hope so too. I for one do.
So let's make sure we get a list of who all those people are, so we let them know when we actually release this.
Sure.
And let's hope they care. If they do, then we'll go on developing it. If they don't, then if they're uses of it for our own internal purposes, great. All right. Now look, in terms of this design, and we're over time here. It's I know you've put lots of effort into this, so I figure. So Michael, have you reviewed all of this stuff?
Not everything in excruciating detail, no.
I don't think. I mean, I think we should just trust Tony on this, because I think this is something where.
I mean, a couple of other people have looked at it, so it's not that nobody has looked at it.
Who else has looked at it?
Andrew Steinerhaar went through everything.
Okay. That's one person. Any others?
Yeah. Tony.
I looked at some of it.
Okay.
I have one question though, which is like something we've been struggling with SQL, and maybe you have a better solution. What is your, like, if you encounter something, say, in the filter, in the condition, that you don't know how to turn into SPARQL? What do you do? Do you fall back into running it in memory? Do you issue a message?
So there are the two cases. If I have an in-memory RDF graph, then it will just go through.
Yeah, sure.
Normal evaluation. If it can't be exported as a SPARQL string, then it will fail.
Okay, so and does it tell you like this is the symbol you're using? I don't know how to translate.
Well, currently there are no sophisticated error messages, just the basic one.
Okay, because this is what I'm struggling with right now. So I imagine that you had a similar problem.
Yeah.
Okay, so look, what are we doing? I need to run here, but
well, I just had one open design question. We have this RDF graph and RDF dataset, and I'm wondering whether we should just unify it into an RDF store. Yeah, that's my...
No idea offhand. I mean, I don't know. From what you've told me, I don't have enough information to say. If you think we should, look, this is clearly its own separate world. I mean, it would be a lot of work. I mean, we've spent probably at least 20 hours of design reviews, maybe more, grinding the SQL database integration system into something which is, well integrated into the language. And I'm fairly happy with what we've got now. But I suspect this would be a similar amount of effort. And, in the end, we would be able to get something which is better integrated into the language. I mean, I'm curious, how efficient are these triple stores? In other words, if we wanted to do, how efficient is the triple store engine? Is it really clever, or is it kind of, nothing special in terms of being able to find these paths and so on?
So it's a very tricky question because it's hard to find comprehensive benchmarks. There are good benchmarks for certain areas of SPARQL.
So you can obviously generate your own completely abstract RDF graph.
Yes, but the problem is having the right distribution and constructing possible syntax combinations that are useful or not. For instance, there are things that test basic features of SPARQL, but I haven't found any good benchmark for property paths. And I have tested some on my own, and my implementation is faster on some queries than other stores, but this is just because I know my implementation. So it's very hard to correctly judge which one is faster.
I understand. So the measure on the space of possible both hypergraphs and queries is very unclear. I mean, like we might imagine that there will be some small world networky thing in the actual graphs of real data in the world, but who knows? And we can generate a random graph with various kinds of distributions, but that's who knows whether that's actually what real in the wild. I mean, presumably one could look at the Wikidata graph and ask what its properties are. Okay, yeah. Look, I think the basic conclusion here has to be, and we probably should look at this one more time. I would really like to know more about what's out there in the world and who we can tell about this and who's likely to care. And by all means, I haven't chatted with Tim Berners-Lee in a while, but we can certainly ask him is he still on this kick? Do you know? Is he still?
Yes, very much so.
Okay.
My understanding is that he very much is still on the Semantic Web kick.
Okay.
And SPARQL is his fingerprints are on it.
Yeah. Okay. All right. Well, it'd be really good to get some more information about who's likely to care about this stuff. And as concretely as possible. And also, if the people who care really are interested in these kinds of programmatic query generation or not, or whether they mostly just want to check a box that say, yeah, we have our data in a triple store, now we can be happy. Okay, but in terms of what you've built here, I mean, it seems like we're not going to grind it all the way to have a full integration. This is really, if you understand something about SPARQL, then you have a chance of being able to do this. It looks pretty nice for that. And I assume that you're going to, it looks like you've got some reasonable documentation. Hopefully you're going to have some tutorials and things.
Yes, and we just had workflow meetings, long ones. So
good. Okay, so there's going to be workflows that basically say, if you've got a triple store, here's how to use it. Is that right?
Things like that, or how to look into a file that you just found. Things like that.
Great. That's great. All right. Okay. I need to go to a different meeting, but I think we should follow up one more time with this.
Okay, so other than the incomplete length and related name changes, any other bigger changes you want?
I don't think it makes any sense, because I
don't think
you
so
guys,
either, because it's more.
You guys have thought through it. I mean, as I'm saying, to do a full integration is a huge amount of work, and I don't think it's worth it.
No, that was never the goal from the beginning.
No, I understand. I mean, the goal is what you've done, which is to make a nice symbolic wrapper around SPARQL. I'm just, it's taken longer than I thought it might. Because there've been all kinds of issues, no doubt. I think the things that we might get out of it are ideas for how to start dealing with graph patterns, integrated graph patterns in the language. That seems like a useful thing to be able to learn from this, and potentially, actual data sources that we can now use, which were SPARQL accessible. But that seems to be, honestly, apart from Wikidata, something of a pipe dream. All right, well, fair enough. Good. No, look, this stuff looks really nice, and it's a good work. All right, I'm going to disappear. Thanks to folks on the live stream, and we've got some other live streams coming up later today. This is a season of getting ready for a big release and live streaming lots of things. So, hope to see you all later.